Problem 4 is a better representation of what you'll likely see in the homework. You are going to see sets of ordered pairs, tables, and graphs quite a bit in this assignment. So a tip for looking at sets of ordered pairs, you want to see if any of the input values, also known as the x values, repeat. We can see we distinctly have a -3, a 5, and a 4. None of these repeat, each has only a single output, so this one is a function. This next one, we have a repeated value here. We have 5 repeated. So because 5 has 2 different outputs, this one is not a function. This last one, while all of our outputs are the same, it doesn't matter. Each input is distinct. So no matter what, we put in a -3, we get a 2. We put in a 5, we get a 2. Completely no mistakes, no guessing. We don't have to decide whether we're going to get a 2 or a 1. It's always going to be a 2. So therefore, because the x values, the input values, do not repeat, this is a function. You're going to have a similar situation with tables. Tables, we look for repeated x values. So we see that we have a repeated 4. We have a 4 going to a 41 and a 4 going to a 30. Therefore, this is not a function. I will say that if this was a 4 going to a 41 and a 4 going to another 41, that would be a function because it's still going to the same output. So if you have a repeated pair of data in the table, that could still be a function. The important thing is that your y values are different while your x values are the same. Looking at the next one, we have no repeated x values. It is a function. In this last one, no repeated x values. We don't care if the y values are repeated as long as there's no repeated x values. This is a function. In this last example, we're going to learn something a bit new. This is called the vertical line test. The vertical line test states that if you draw a vertical line going up and down anywhere in the graph, it only touches the graph at most one time. So no matter where we draw a line straight up and down in this, we do not touch more than one point. Therefore, this is a function. A function can be a set of points. I mean, that's essentially what our first example was. It was a set of points. This is just those set of points graphed. A set of points can be and often is a function. Let's look at this parabola. If we were to draw a vertical line anywhere on this parabola, it's only going to touch the parabola at most one time. It's never going to go through the same graph twice, so this guy is a function. In our last example, we can see if we draw a vertical line, it's not a very straight line, but pretend it is, it touches our graphed relation many times. Therefore, this is not a function.